Hey viewers, welcome back to our YouTube channel. In this video, we are going to discuss about the container with most water, where we are initially given with an array called heights, and every element present in the array is represented as a vertical line, where the line's length is given as the element. For example, if I have the 1, the length of this line is 1. If I have 2, the length is 2, etc. And we have to figure out the two lines that together with the x-axis form a container such that the container contains the most water. In order to break this down into a simpler terminology, if I say that if I have one line with a length 1 and another with a length 2, I have to figure out how much of maximum water that I can store. Okay, if I have this as consider as a vertical line and this as another vertical line, if I store a water more than this length, it gonna overflow, right? Therefore, the maximum water that I can store is the minimum of both two, like this line and this line, and the width of this. By using the width and the minimum of both this, I can figure out. Let's consider the width as something as y, and I know the the length is 1. I can figure out 1 cross y, which is the area of the both two lines, like the maximum water that I can store between these two lines. If it is not clear for you, let me pick the example. In this example, I have the element starting from 0 index and going towards the 8 index. If I draw it into a pictorial form, it looks something like this. And if I can see that at the 0th index, I have the element or value as 1, and here also the vertical lines have the length as 1. The maximum area that I can store between index 0 and index 1 is this much, right? Here the width is 1 and the length is 1. The area that I can store between both of them is again 1. Got it? Therefore, the entire area between 0 index and 1 index is 1. In this way, we have to figure out what is the area that possible area that we can have between every index with every other index, like from 1, 2, 3, 4, 5, etc. And this intuition gives us a little bit clue about the brute force solution, like figuring out every element and figuring out the maximum area and storing it in the result, and at the end we have to return. And this is one of the famous question. It is asked in Google, Amazon, TCS, Microsoft, etc. So let's quickly discuss the brute force solution for this approach. As we discussed earlier, we are going to try each and every possible way to figure out the maximum area. First, I stand it here and I'm going to look at what is the maximum area that I can have here. As I said that if I have one vertical line which is of length 1 and another vertical line which is of length 8, what is the maximum length that we can store? We can't store the water around this, right, because it overflows. We can only store up to this level with the minimum of both. Here the minimum is 1 of 1 and 8, therefore we can store up to this level only, one level only. Makes sense, right? And the another important thing is to figure out what is the width of this. The width is easily calculated by using the difference of the both indexes. Let me pick the index of 8 as 1 and index of 1 as something like 0. Therefore, their width becomes 1 minus 0, which is 1. Right? Makes sense. And the area becomes 1 cross 1, which is the length versus width, which gives me as a 1. This is the area that I can store. Makes sense, right? Therefore, I'm going to use this same thing for each and every possible elements and figure out the answer. And let's simulate this with the example. I am standing it here. What is the area that I can form with this index? Got it? First of all, I have to figure out the minimum of both, right? The minimum of both is 1, and the width is the index differences, 1 minus 0, which is 1. Therefore, my maximum area, I can update it with 1. Got it? I am done with the 0 index and I have to move it forward. When I move it forward, what is the minimum of both? Still 1, and the width is 2 minus 0, which is 2. Therefore, area becomes 2. Makes sense, right? I'm going to do with this. The width becomes 3 minus 0, which is 3, and the length is still the minimum of both, which is 1. I'm going to get the answer as 3. And I have to do this with entire elements of the heights array, right? And figure out at the end I'm going to get a optimal solution, or you can say that the maximum area between the one index and the last index. Makes sense, right? Okay, let's figure out this out. First of all, I am at index 1, and the width is the 8 minus 1, which is 7, and what is the minimum of 8 and 7? The minimum of 8 and 7 is 7 itself. 7 cross 7, which is 49, and this is the maximum area that we can store. Therefore the answer is 49. Makes sense? And let's discuss the time complexity for this approach. As I'm trying each and every possible way, I'm gonna have two for loops, like one for loop for I, which goes from 0 till the n, and another for loop j, which goes from I plus 1 to the n. And I'm gonna length could be figured out by length is the minimum of heights, right? Yeah, heights of I comma heights of j, because we can't store the maximum height vertical line as the length. We can only consider the minimum one, right? And the width becomes their index difference, j minus I, and I'm gonna update each time. Every time I'm gonna update maximum area as the maximum area comma length into width, and this is the pseudocode for this, and at the end we are gonna return the maximum area. Got it? And let's discuss the space time and space complexity for this approach. As we know that this loop takes a time complexity of order of n, and again this takes a time complexity of order of n entirely. So and everything is going to take a constant time complexity. Therefore the time complexity becomes order of n square, whereas the space complexity is order of 1, because we are not using any external data structure to store the result. We only dynamically updating the result based upon the condition. Like if it is greater, only we are picking it to the max area. And if we see the constraints from this problem, it is 10 power of 5. What is 10 power of 5? The maximum length the heights array can contain. Therefore 10 power of 5 whole square, which will become 10 power of 10, and we can only perform 10 power of 8 operations or lesser. Therefore definitely 10 power of 10 will give us a TLE, time limited exceeded. Therefore our solution will break. And let's discuss the optimal solution for this problem. Using the optimal solution, we can do this same problem with a time complexity of order of n and a space complexity of order of 1. But how? Let's simulate. The optimal solution for this problem uses a approach called two pointer, where initially we take a left pointer and a right pointer, and the left pointer will place towards the first index, and as usual the right pointer will be placed at the last index. And let's figure out how we're gonna move the left pointer towards the right and right pointer towards the left. Initially we have to check the height of the both, but before we are gonna check, we're gonna consider the max area to be updated, because at current level I have to update, right? And the max area will be same, the max of max area and the area of the both, and it follows the same approach that we have been following previously. First we have to find the length and the width, then do a length cross width, and done with this. But how we gonna update the left and right pointers? In this case we're gonna see that we try to move the left pointer towards right only if the left index element is lesser than the right index element. If you see that the left index element is 1 and the right index element, which is 7, you're gonna see that, yeah, now see, if I am at the left position, if I want a greater area, I should definitely change the smaller one, because the bigger one can't do anything with this, because I'm calculating the length depending upon the minimum one. Therefore I'm going to change the minimum one to get a better answer. I don't know whether the next element will be a lesser one or a greater one, but I'm going to change it, because it's going to give as a different answer. Because if I change this, I still have the problem with the minimum one. Therefore if I found the left value which is lesser than the right value, then please increment the left pointer. Got it? Or else do the opposite of this, decrement the right pointer. And let's simulate this. In this case I have 1 and 7. Here left value is lesser, and we can calculate the maximum area, which is 8 minus 0, which is 8, and the minimum of both is 1, 8 cross 1, which is 8. Move the left pointer towards forward. Here you're gonna see that the area, the width is 8 minus 1, which is 7, cross the length minimum of both is 7, 49. Update it with. Now see that here the interesting thing, among these 8 and 7, which is the minimum one? this is the minimum one. To get a good element or to get a good answer, we're gonna don't want this minimum element. We're gonna move towards the left. Either we're gonna get a 3 or we're gonna get 11. I don't care. I just want to change my minimum number. Therefore, I move the right pointer towards left. Now the area becomes, which is 7 minus 1, 6 cross minimum of both is 3, 18, but it is still lesser. I'm not gonna update it. And here the same thing happens. Which is the minimum? Right pointer is the minimum. Again I'm gonna decrease the right pointer. Now if you see that the width becomes 6 minus 1, which is 5, and the minimum of both is, they are both same, right? 8 itself. Now get the answer as 40, but it's still lesser than the max area that we have seen earlier. I'm not gonna update it. And here when I have the case left and right are equal, I can do either of the things, like I can move the left pointer towards the front or right pointer towards the left. But as here I not included a equal to case, it's gonna fall into else block, and right block right will be decremented. Now right is here. Now the area becomes 5 minus 1, which is 4 cross the minimum of both is 4, which is 4 plus 4, which is 16. It's still lesser than the maximum area. Not gonna update it. Again the smaller value will be choose it like among the left and right. 4 is the minimum. I gonna move towards the left. The width becomes 4 minus 1, which is 3 cross what is the minimum of both? 5, 15. Not gonna update it. Same again, move it towards the left because 5 is lesser than 8. Now the width becomes 3 minus 1, which is 2 cross minimum of 2 is 2, which is 4. Still it's lesser. Gonna move it towards the left. Here I can say the 2 minus 1, which is 1 cross which the minimum is 6, which is 6. Got it. It is still lesser than the maximum area, and now it's become both are pointing towards the same element. And as we know that if I standing at the same, I can't store anything towards left and anything towards the right, because there is no thing that is gonna stopping it, right? Whenever I found if left and right are pointing towards the same, then please drop out and return whatever you have seen as the maximum area. And if you understand this, let's quickly code it up. As I said earlier, we're going to take a left pointer which is points to 0 and a right pointer which stands to the last index. If n is the length of the heights, then the right pointer could be n minus 1, right? And I can say that while left should be lesser than the right, because if left and right both are equal, it doesn't make sense, right? Because a single vertical line can't store a water, right? Now the length becomes the minimum of both, the minimum of heights of left and the heights of right, whereas the width becomes the difference of both index, which is right minus left, because right is have a greater value. Therefore I gonna update the maximum area. Initially I have to declare the maximum area, which is the lowest possible area you can store is 0. Therefore the maximum area is max of maximum area comma length cross width. Done. And here comes the shifting the pointers. If the heights of left is lesser than the heights of right, therefore I gonna get the left has a lesser value, therefore I gonna move it towards a better answer or better area. I gonna change my minimum value, therefore the left will be incremented, or else the right will be decremented. Got it? And at the end, when we hit a condition like when left and right are pointing towards the same element, at that position I gonna return the maximum area. Make sense? And let's discuss the time and space complexity for this approach. Initially the while loop will run until left and right are pointing towards the same element, right? As we are only moving towards the right by left pointer and left by right pointer, we are not gonna seeing every element more than once. We are only seeing it only for once, right? Therefore I can say that the entire time complexity of this for loop will be order of n. And coming to the space complexity, I am not using any external data structure like arrays or sets or hash maps. I am using constant variables. My space complexity is or rough one, and I can say that this is the most optimal solution. And if you really like this video, then please do like, share and subscribe. And if you have any queries, please put them in the comment section. Thank you.